Even if you're using Kubernetes, you still need to protect data inside your deployments. With Storware Backup and Recovery, you can easily do that, and not only metadata of the deployments is being protected, but also the persistent volumes. In this short video, I'm going to give you a short overview what is possible with Storware Backup and Recovery. Let's start by logging into the administrative user interface. First, I see the dashboard, and because Storware Backup and Recovery supports a wide range of the different sources, well, virtual environment is the section that we are going to be interested in. I see obviously the status of my previous backups and the status of my nodes, so node data mover, that's the actually synonym, and nodes are responsible for actual data movement from your Kubernetes cluster to the backup destinations that you define. Using Configuration Wizard, you can easily specify obviously the location settings, then you have the node availability check, and this is the moment where you are able to specify a new container-based environment, so container section at the bottom of the screen here, and you can go and click Next. In this URL, you specify the URL to your Kubernetes cluster, your username, and optionally the token in this case. So in our case, it really depends if you're using SSH access to your environment or rather just token access. From this wizard, you can also define backup destination. So that's usually what you do once per deployment, but you can, as you can see, we support not only file system and object storage, but also some other enterprise-grade backup providers such as Dell, IBM, Veritas, or Micro Focus. We also recommend you to use file system synthetic backup provider, because if you're using incremental, which is doable with the Ceph RBD using Kubernetes, you will have faster recovery later of your backups. File system can also be used together with backup destination, so you don't have to copy data twice between the staging space on the node and later to transfer it to other storage. This wizard also allows you to have SLA configuration, so if you would like to, using the same wizard, you can set up already base backup SLA for your environments, and internal database backup, which is used for the metadata of the solution itself. So that's a very important aspect. We really encourage you to that just in the beginning. In the virtual environment section, you have everything what you need, and you can also add infrastructure related items from the infrastructure subsection. Notice that I have my Kubernetes already added here. That's the URL I have mentioned to you earlier, and I can invoke, let's say, inventory synchronization process. It is also done automatically to detect the nodes, so Kubernetes nodes that you are using, especially important from the licensing point of view, because here is the place where you can actually license specific worker nodes, not only the control plane. So we charge you for the worker nodes, and this is the place where you can decide which of them are going to be used for that. We detect obviously the clusters, the storage class. The one that we are going to use for this demo is this one, CSI RBD. So I have a deployment based on the Ceph RBD volumes, some networking, projects. So if you would like to limit the scope of the backups to the specific project, it's also doable. Filter by the project, or maybe just automatically assign deployment from the project. That's why we also discovered this during the inventory synchronization. And projects allow you also to create quotas. So users running specific project will have only specific number of backups being allowed to be done. So you will have, let's say, 5 backups per 24 hours, let's say, time window. It will just give them hard limit, and no more backups are going to be allowed for this specific project. Now let's start maybe with some backups. So I have a filter in here, and I would like to filter Kubernetes and invoke my Ceph-based MariaDB deployment in here. is going to use a crash consistent backup because we are using snapshots for the Ceph volumes in this case, and let's initiate a backup. Backup consists of two steps actually. There is an export phase and one or more store tasks. We support secondary backup destination as well, so you will have one store task that is actually moving data to your primary backup destination, optionally secondary store task that is simultaneously transferring to your, let's say, S3 bucket. In the details, notice here that I have some daily activity statistics, some backup size, time or rate statistics important for troubleshooting the bottlenecks, and at the bottom I have the backup history. My backup is currently running, restore history, some snapshots if they are still kept on the hypervisor. Notice that if you don't need incremental backups, snapshots are going to be removed automatically after the backup itself. However, if you are using Ceph, for instance, we will have to keep the snapshot for future incremental backups to track the changes between and compare the snapshots using this Ceph APIs. This actually section corresponds to your persistent volume claims, and this is allows you to exclude specific claims from your Kubernetes deployments from being backed up, and settings if you would like to execute some custom actions before and after the actual backup is taking place. Maybe you would like to quiet your environment. This setting actually is going to pause your deployment, so we don't recommend that for environments that they need to run all the time. But you may just execute also some custom commands on your environment to quiet your database, maybe in a different way using some SSH command in that case. Now the backup has completed, and notice that export task has been invoked. Then I had a store task. Store task is actually using the local backups backup destination. This one is file system synthetic. Now let's invoke the recovery. So again, I'll have my Kubernetes environment, and I would like to use the one that I have already run and invoke restore to the hypervisor. This is going to be demo project and the same hypervisor manager. I can have more. Let's optionally specify the restore 1 as the suffix. Then what I can customize is to specify the storage class. So I can use different one. Maybe you have gold, silver, bronze corresponding to a different storage class, and you would like to have a different volume the type being used. This one didn't have any specific networking, and now I'm able to optionally override if such a deployment already exists, or power it on just after the deployment has succeeded. So now I'll invoke the restore operation. Again, it's a two-step process. If you have a chain of increments, like for the Ceph, I have mentioned that, and you have, let's say, non-synthetic backup provider, maybe S3 bucket, this would merge all of the chains of this backup before being imported. So import is the second phase of the restore process back to the Kubernetes. Notice that the restore has already completed, but restore back to the Kubernetes environment is only one of the options available. We also support file level recovery if it's raw volume, like Ceph, for instance, is, and you can use the mount operation in this case. So you can automatically mount file system within your volume, so you could browse easily what is inside. Or you can share such raw volumes over iSCSI as well. So if I have, like here, Ceph base and volume, I would also be able to expose it directly from the node, so that I can later mount it directly in the external system. So I can add clients here. One of such volumes I have already here, and in the mounted backup section I can browse it directly from my browser here, and restore individual files, whatever is needed for me to be grabbed directly from this backup, or remotely upload it to the external system. I can also grab these files directly from the node if the dataset is large. For the larger environment, we also support the recovery plans. So similar to the backup SLAs, like I have backup SLA in here for daily full backup, and I'm able to automatically assign deployments based on the labels that you have in the Kubernetes, or maybe you have some naming convention in your deployments in general, and maybe limit to the specific clusters or projects. I can define multiple rules in such backup SLAs as well, and I'm able to specify inside each rule if it's where it's supposed to be stored, where the backups are supposed to be stored, how long they should be kept, and according to which schedules backups are going to be executed. Optionally, I can use secondary backup destination if my primary is synthetic. That's the requirement in this case. Multiple rules means multiple backups, separate backups with separate exports, but secondary backup destination, when it's enabled, it actually results in 2 stores instead of 1 store task in your console. Recovery plans, on the other hand, is the opposite way. So you would like to restore batch of the deployments back to your environment. So whenever you create a recovery plan, like this is the RP1, let's say, then you are able to create rules, and each rule needs to correspond to the specific type of the workload. Like I have, let's say, my Maria in here, it's for Kubernetes, and I would like to recover this specific instance. Notice that I have schedules optionally, which I can assign here to the recovery plan, and I also can skip this section and I can just invoke this recovery plan on demand. Restore parameters allow me to specify the common parameters for all of the deployments. So especially it may be important to have a specific prefix for this deployment so that I'm able quickly to distinguish which one has been created by the recovery plan and which are manually created. Maybe I would like also to remove existing environments based on its name. Having multiple backup destinations, remember, it allows me to quickly integrate with existing file system backup providers, especially if you would like to use the synthetic one. Maybe you will have object storage in the cloud, or maybe you have on-prem S3 based S3 compatible backup destination, or enterprise vendors such as the Dell, IBM, Veritas, or Micro Focus. If they are already in your data center, we can easily add them as well. I really encourage you to download and install Storware Backup and Recovery, connect to your Kubernetes cluster and see how it works. And thank you for watching.